I'm hoping that you know your perfect squares at least up to 12 squared. So normally I would give you this list, but I thought, let's make them write it down. So 1 squared is 1, 2 squared, 4. Keep filling those in. 11 squared is 121. 12 squared is 144. Some of you have also memorized that 13 squared is 169. If you can remember that 13 squared is 169, then you can remember 14 squared because you just take the 6 and the 9 and trade places. So 14 squared is 196. 15 squared is 225. Now, some other perfect squares that are commonly used, particularly in this section, are 16 squared, which is 256. Another one that's commonly used is 25 squared, which is 625. Now, the reason that this section really likes to use 256 and 625, the square root of 256 is 16. 16 is still a perfect square, so it's kind of like a double-decker perfect square. So that's why they're going to be using 256 and 625 in this section. Now, yesterday we did a lot with the difference of two squares. I feel like you all recognize difference of two squares pretty quickly. If you see a perfect square minus a perfect square, you find what they are the perfect square of and then plus, minus in the parentheses. So our first example is 16x to the 4th minus 81. What is 16x to the 4th the perfect square of? 4x squared. So before, we would have something like 16x squared. Now we're going to have 16x to the 4th. This is called quadratic form, when it follows the same patterns as before, but with larger exponents. 81 is the perfect square of 9. So this factors into 4x squared plus 9 times 4x squared minus 9. I'm going to zoom this way in so I have a little bit more room to write. If you have x squared plus, you're pretty much done. If it's a binomial, two terms, like 4x squared plus 9, and it's x squared plus, we do not have a sum of two squares. We only have a difference of two squares. So this first set of parentheses is done. 4x squared plus 9. However, the second set of parentheses, we have x squared minus. And anytime you see x squared minus, you are probably not done. 4x squared is the perfect square of 2x. 9 is the perfect square of 3. So that one factors further into 2x plus 3 times 2x minus 3. And now, that is fully factored. The other one won't factor because it's 4x squared plus. And we don't have a sum of two squares. We have a sum of two cubes. We don't have a sum of two squares. So the things that you need to check for, and this is actually a good time to bring this up, once you've factored the first time, check to see if you have x squared minus, you probably aren't done. If you have x cubed plus or x cubed minus, you probably aren't done. Because we do have patterns for the sum of two cubes, the difference of two cubes, and the difference of two squares. We do not have a sum of two squares. All right, example B. 625, we just talked about 625. 625 is the perfect square of 25. X to the 8th. What is x to the 8th the perfect square of? X to the 4th. X to the 4th times x to the 4th becomes x to the 8th. And 256 is the perfect square of 16. And you might notice that those are also perfect squares, so this is probably going to be a multi-level problem. So 25x to the fourth plus 16, 25x to the fourth minus 16. We don't have any special patterns for x to the fourth plus, so that one's done. But 25x to the fourth minus, I know it's not x squared minus, but it's x to the fourth minus. 25 is the perfect square of 5. I forgot to change colors. X to the fourth is the perfect square of x squared. 16 is the perfect square of 4. So we can break this into 5x squared plus 4 times 5x squared minus 4. All right, 5x squared plus 4, that one's done. 5x squared minus 4, can we factor that one more? The x squared minus 4 looks like we might be able to, but is 5 a perfect square? No, so that one is done. It is not a perfect square minus a perfect square. It's just almost. All right. Do you see a problem with example C? It's negative 16 n to the fourth, and it's plus in the middle. So here's a fun little trick. Let's factor negative 1 out of both of the terms. Negative 16 n to the fourth divided by negative 1 is positive 16 n to the fourth. And positive 625 divided by negative 1 is negative 625. And now the binomial in the parentheses looks like something that we can factor. So on your own, please try to factor 16 n to the fourth minus 625 and think about if you can factor it more after that. So I've got the negative 1. This is the perfect square of 4n squared. This one's the perfect square of 25. So 4n squared plus 25, 4n squared minus 25. 4n squared plus is done. So we have negative 1, 4n squared plus 25, 4n squared minus 25. 4n squared is the perfect square of 2n. 25 is the perfect square of 5. So that breaks into 2n plus 5, 2n minus 5. And that whole thing is our fully factored form. For example D, what I notice here is the exponents are pretty big. I notice that the first and last term both have numbers and letters, which means that there's probably something that these three terms have in common. So the first term has a 3. It'd be really nice if we could divide all of these things by 3. Can we divide them all by 3? Yes, we can. And because the last term has x squared, it'd be really nice if we could also factor x squared out of each term. And I believe that we can. So 3x squared we're going to pull out of each term. In the first term, 3 divided by 3 is 1. X to the 6th, take 2 factors of x out. What are you left with? X to the 4th. The middle term, 15 divided by 3 is 5. You've got x to the 4th. You're taking 2 of them out. You're left with x squared. 18 divided by 3 is 6, and we're taking all of those x's out. Now, you do not need to write this part. I'm going to write this down toward the bottom, so like way off your paper. We are used to seeing it as x squared plus 5x plus 6. Do you see how that is very similar to what we have, but just slightly different? This is x squared and x to the first. Up here we have x to the fourth and then x squared. X squared is half the exponent that x to the fourth is. Now let's think about how we would have factored it if it was just x squared plus 5x plus 6. Which two numbers multiply to give us 6 and add up to 5? 3 and 2. So this is x plus 2, x plus 3. Now you can draw the blanks if that helps you, but you don't have to. If you can start getting toward just writing the numbers in the parentheses, it's going to be easier for you. When we do this, x times x gives us x squared. So up here, what we have is these two things have to multiply to give us x to the fourth. So it needs to be x squared and x squared. We're still looking for the two numbers that multiply to give us 6 and add up to 5. So this is x squared plus 2, x squared plus 3. If you were to multiply this out, or FOIL, as some people say, I hate that word, x squared times x squared is x to the fourth. X squared times 3 and x squared times 2, those would add together to give you the 5x squared in the middle, and then the 2 times the 3 would give you the 6. Don't forget that we have the 3x squared out front. And again, check to see. If you have x squared minus, you're probably not done. If you have x to the third plus or x to the third minus, you may have more factoring that you need to do. But I think this one is done. Well, I know that it's done. All right, let's look at example E. Whoa, x to the 13th. I really hope we can factor some x's out. So it'd be really helpful if we could factor out 2, because I really don't want to have a number in front of my trinomial. It's easier to factor if there's no number in front of your trinomial. And it looks like we can pull x to the 5th out. 2 divided by 2 is 1. If you have x to the 13th, and you take 5 of those x's out, how many x's are going to be left? X to the 8th. 10 divided by 2 is 5. X to the 9th, take 5 of them out, you're left with x to the 4th. 8 divided by 2 is 4. We're pulling out all of the x's. Quadratic form is the type of factoring that we're doing right now. Do you notice that x to the 8th and x to the 4th, 4 is half of 8. That's how you want it to be set up for this to work. So we are going to have 2x to the 5th in front, and then 2 sets of parentheses. These two have to multiply to give us x to the 8th. So these have to be x to the 4th and x to the 4th. What two numbers multiply to give you 4 and add up to 5? 1 and 4, and they both need to be plus. Now again, if you need to do blank times blank equals 4, blank plus blank equals 5, you can, but we're factoring the same as we did before. Would either of those break down further? Are any of them x to the 4th minus? No, so that is done. On F, it is supposed to be 30w squared, not 30w2. So make that correction and try F on your own. Okay, you can factor 5w squared out of the trinomial. You're left with w to the 6th minus 5w to the 3rd plus 6. Because it's w to the 6th, the two things need to be w to the 3rd. Also, what might help you, whatever's in the middle, that's what the w needs to be in the parentheses. To multiply to give you positive 6, they either both have to be positive or they both have to be negative. Since we're adding up to negative 5, that means this is negative 2 and negative 3. Now, I see w cubed minus, which means it might be the difference of two cubes, But are 2 or 3 perfect cubes? No, so there's no more to do. You are done.